What if I told you that right now, at this very moment, there could be civilizations thriving on worlds so distant that their light takes thousands of years to reach us? What if the most profound discovery in human history isn't waiting to be found in some laboratory or archaeological dig, but is instead floating through the cosmic void, perhaps even watching us as we watch them? Forget everything you think you know about alien life. Forget the Hollywood stereotypes of little green men and flying saucers. The reality of extraterrestrial existence is far more spectacular, far more diverse, and yes, far more terrifying than anything our imaginations have conjured. New discoveries are shattering our assumptions about life in the universe, revealing evidence so compelling that even the most skeptical scientists are beginning to whisper the unthinkable. We are not alone. Today, we're embarking on a journey that will take us billions of miles beyond our familiar solar system, into the vast expanse of space where entire worlds await discovery. We'll explore planets where diamond rain falls from methane skies, where liquid water oceans hide beneath frozen surfaces, and where forms of life so alien that they challenge our very definition of what it means to be alive might be thriving right now. This isn't science fiction anymore. This is science fact. And by the end of this exploration, your entire perspective on humanity's place in the cosmos will be fundamentally transformed. Before we dive into the cosmic deep end, I want to know something about you. Drop a comment right now telling me where you're watching from and what time it is in your part of the world. Are you watching this during your morning coffee in New York? Perhaps it's late night in Tokyo? Maybe you're somewhere I've never even heard of. I'm genuinely curious about this global community we're building together, and it's fascinating to think that while we're all contemplating the possibility of life on distant worlds, we're connected right here, right now, across our own planet. The scale of cosmic possibility. Picture this: you're standing on a beach at midnight, looking up at the stars. Every single point of light you see represents not just the sun, but potentially an entire solar system. Now imagine that what you're seeing with your naked eye is less than 1% of the stars in just our galaxy alone. The Milky Way contains somewhere between 200 and 400 billion stars, and each of those stars could host multiple planets. But here's where it gets truly mind-bending. Our galaxy is just one of an estimated 2 trillion galaxies in the observable universe. If we do the math, we're looking at roughly 10 to the power of 24 stars in the universe. That's a 1 followed by 24 zeros. To put that in perspective, that's more stars than all the grains of sand on every beach on Earth. The Drake equation, formulated by astronomer Frank Drake in 1961, attempted to estimate the number of communicating extraterrestrial civilizations in our galaxy. While the equation involves many unknowns and estimates vary wildly, even conservative calculations suggest thousands of potentially communicating civilizations in the Milky Way alone. The psychological impact of these numbers cannot be overstated. For most of human history, we believed Earth was the center of the universe. Then we discovered we orbit the sun. Then we realized our sun is just one of billions in our galaxy. Then we found out our galaxy is just one of trillions. Each revelation has been a humbling step in understanding our cosmic insignificance, but also a thrilling expansion of the possible. Carl Sagan once said, "The universe is not only queerer than we suppose, but queerer than we can suppose." This queerness extends to the possibility of life itself. If life arose on Earth, a planet that's only 4.5 billion years old in a universe that's 13.8 billion years old, then statistically speaking, life should have had multiple opportunities to emerge elsewhere, potentially billions of years before it appeared here. The Copernican principle suggests that Earth is not unique or centrally located in the universe. Applied to biology, this principle implies that life on Earth should not be unique either. We call this the principle of mediocrity, not because life is mediocre, but because Earth and the life upon it should be relatively typical examples of what might exist elsewhere. Recent discoveries have only strengthened these arguments. We've found that the building blocks of life, organic molecules like amino acids and nucleotides, exist throughout space. They've been detected in meteorites, in the interstellar medium, and even in the atmospheres of distant planets. The raw materials for life, it seems, are ubiquitous. But perhaps the most psychologically profound aspect of contemplating alien life is how it forces us to confront our own existence. Are we alone in our consciousness? In our capacity for love, creativity, and wonder? Or are there beings out there right now, on worlds we can't even imagine, experiencing their own version of consciousness, perhaps in ways so alien to us that we couldn't even recognize it as such? The exoplanet revolution. 25 years ago, we knew of exactly 0 planets outside our solar system. Today, we've confirmed the existence of over 5,000 exoplanets, with thousands more candidates awaiting confirmation. This represents one of the most rapid and revolutionary expansions of human knowledge in our species' history. The first exoplanet discovered around a Sun-like star was 51 Pegasi b, found in 1995 by Michel Mayor and Didier Queloz, a discovery that would eventually earn them the Nobel Prize in Physics. But this planet was nothing like what scientists expected to find. It was a gas giant, similar in mass to Jupiter, but orbiting its star once every 4.2 days. Its surface temperature was estimated at over 1,000 degrees Celsius. This was a hot Jupiter, a type of planet that shouldn't exist according to our understanding of planetary formation. The discovery shattered our assumptions about planetary systems. We had assumed that other solar systems would look like ours, with small rocky planets close to the star and gas giants farther out. Instead, we found a universe of planets so bizarre they seemed like science fiction. The Kepler Space Telescope, launched in 2009, revolutionized exoplanet detection. Using the transit method, where it measured the tiny dimming of a star's light as a planet passed in front of it, Kepler discovered thousands of exoplanets. But more importantly, it revealed the statistical distribution of planet types across the galaxy. One of Kepler's most significant discoveries was that the most common type of planet in the galaxy appears to be something we don't have in our solar system: super-Earths. These are planets larger than Earth but smaller than Neptune, with masses between 1.5 and 10 times that of Earth. They orbit closer to their stars than Mercury orbits our Sun, completing their years in just days or weeks. The psychological impact of these discoveries cannot be understated. Each new exoplanet is a world with its own story, its own geological history, its own potential for harboring life. Consider Kepler 452b, often called Earth's cousin. It's about 60% larger than Earth and orbits within the habitable zone of a Sun-like star. Its year lasts 385 days, remarkably similar to Earth's. If you could stand on its surface, you would see a sun very much like our own. But it's the planets that challenge our imagination that are perhaps the most intriguing. Take HD 189733b, a deep blue planet where it rains glass sideways in 7,000 km/h winds. Or consider Kepler 16b, which orbits 2 suns like the fictional planet Tatooine from Star Wars. There's WASP 12b, which is being slowly devoured by its host star, losing about 600 million tons of material every second. The James Webb Space Telescope has taken exoplanet science to an entirely new level. Unlike previous telescopes, Webb can actually analyze the atmospheres of distant planets by studying how starlight filters through them. In 2022, Webb detected water vapor in the atmosphere of WASP 96b, a gas giant located 1,150 light-years away. The precision of these observations is staggering. Scientists can determine not just what gases are present, but their concentrations and distributions. But it's the rocky, Earth-sized planets that capture our imagination most powerfully. These are the worlds where liquid water might exist, where the chemistry of life as we know it might unfold. The habitable zone, or Goldilocks zone, around a star is the region where temperatures are just right for liquid water to exist on a planet's surface, not too hot and not too cold. LHS 1140b represents one of the most promising targets in our search for life. This rocky super-Earth orbits within the habitable zone of a nearby red dwarf star. Recent observations suggest it might retain a substantial atmosphere and could potentially host liquid water. If confirmed, it would be one of our best bets for finding signs of life beyond our solar system. The diversity of exoplanets has forced scientists to expand their definition of habitability. We now consider not just the traditional habitable zone, but also the possibility of subsurface oceans on moons like Europa and Enceladus in our own solar system. This concept extends to exomoons, moons of exoplanets that could potentially harbor life even if their host planets are uninhabitable gas giants. Perhaps most intriguingly, we've discovered that many exoplanets exist in multiple star systems. About half of all Sun-like stars are part of binary or multiple star systems, creating complex gravitational dynamics and potentially exotic conditions for any planets that might orbit them. Imagine a world with two sunrises, where the interplay of multiple stars creates seasons and weather patterns unlike anything on Earth. The search for biosignatures. The next phase of exoplanet exploration goes beyond simply finding worlds. It's about determining which of these worlds might actually harbor life. This search relies on detecting biosignatures, chemical indicators in a planet's atmosphere that suggest biological processes. On Earth, our atmosphere is dramatically different from what it would be without life. Oxygen makes up about 21% of our atmosphere, but this is highly unusual. Oxygen is a reactive gas that quickly combines with other elements, and would disappear from the atmosphere in just a few million years without constant replenishment. The only known source of large quantities of atmospheric oxygen is photosynthesis by living organisms. The combination of oxygen and water vapor in an atmosphere is particularly significant. These two gases react with each other, so their simultaneous presence suggests an ongoing process that's actively producing one or both. On Earth, that process is life. But oxygen isn't the only biosignature scientists are looking for. Methane in the presence of oxygen is another strong indicator of biological activity. On Earth, methane is produced by various life forms, from bacteria in wetlands to cows' digestive systems. Methane has a relatively short lifetime in the atmosphere when oxygen is present, so detecting both simultaneously suggests active production. Other potential biosignatures include phosphine, dimethyl sulfide, and even industrial pollutants. Yes, you read that correctly. Advanced civilizations might pollute their atmospheres in detectable ways, and these artificial compounds could serve as technosignatures, indicating not just life, but intelligent life. The James Webb Space Telescope is at the forefront of biosignature detection. Its unprecedented sensitivity and precision allow it to analyze the atmospheres of Earth-sized planets around nearby stars. In 2023, Webb successfully detected carbon dioxide in the atmosphere of WASP-39b, demonstrating its ability to identify specific molecules in exoplanet atmospheres. But detecting biosignatures isn't straightforward. False positives are a constant concern. Oxygen can be produced by non-biological processes, such as the photodissociation of water molecules by ultraviolet light. Methane can be generated by geological processes like serpentinization. Scientists must carefully consider all possible explanations before concluding that a biosignature indicates life. The search for biosignatures also requires us to think beyond Earth-based life. Silicon-based life forms might produce different atmospheric signatures than carbon-based life. Life in subsurface oceans might not affect atmospheric composition at all. We might need to look for other indicators, such as seasonal variations in atmospheric composition that could suggest large-scale biological processes. One particularly intriguing concept is the detection of vegetation red edge, a sharp increase in reflectance at near-infrared wavelengths caused by chlorophyll in plant leaves. If alien plants use similar light harvesting mechanisms, their planets might show the same spectral signature. Imagine the moment when we first detect the reflection of alien forests on a world dozens of light years away. The psychological preparation for discovering biosignatures is as important as the technical preparation. The detection of life beyond Earth would be one of the most significant discoveries in human history, comparable to the development of language, the invention of agriculture, or the discovery of DNA. It would fundamentally alter our understanding of our place in the universe and our responsibility as potentially one of many intelligent species. But what if we detect biosignatures that we can't explain? What if we find atmospheric compositions that don't match any known biological or geological processes? These anomalies might be our first glimpse into truly alien biochemistry, life forms so different from Earth-based life that we don't yet have the theoretical framework to understand them. Extreme environments and exotic life. Life on Earth has repeatedly surprised us with its ability to thrive in environments once thought to be completely inhospitable. These discoveries have revolutionized our thinking about where life might exist elsewhere in the universe and what forms it might take. Deep in the ocean, around hydrothermal vents where water temperatures exceed 400 degrees Celsius, entire ecosystems thrive without any energy from the sun. These communities are based not on photosynthesis, but on chemosynthesis, where bacteria derive energy from chemical reactions involving hydrogen sulfide and other compounds. Giant tube worms, ghostly white crabs, and bizarre fish populate these alien-like landscapes on our own planet. In the Atacama Desert of Chile, one of the driest places on Earth, microorganisms survive in environments that receive no rainfall for decades at a time. Some of these organisms can remain dormant for years, only becoming active when brief moisture becomes available. They've evolved mechanisms to extract water from the atmosphere and to protect their DNA from intense ultraviolet radiation. Perhaps most remarkably, life has been found living inside solid rock kilometers below the Earth's surface. These endolithic organisms derive energy from the chemical breakdown of minerals, living completely independently of the surface world. Some of these deep subsurface communities might have been isolated for millions of years, representing entirely separate evolutionary lineages. Tardigrades, microscopic animals also known as water bears, can survive in the vacuum of space, withstand radiation doses that would be lethal to humans, and endure temperatures from near absolute zero to over 150 degrees Celsius. They can dehydrate to just 3% water content and remain viable for over a decade before being revived. These discoveries have profound implications for the search for extraterrestrial life. If life on Earth can survive in such extreme conditions, then the range of potentially habitable environments elsewhere in the universe is much broader than previously imagined. Consider the possibility of life in the subsurface oceans of Jupiter's moon Europa or Saturn's moon Enceladus. These moons have global oceans beneath their icy crusts, with more water than all of Earth's oceans combined. Near the ocean floor, hydrothermal vents similar to those on Earth might provide the energy needed for life. The ice crust above would protect any life from the intense radiation environment around Jupiter and Saturn. But why stop at water-based life? On Saturn's moon Titan, lakes and rivers of liquid methane and ethane flow across the surface. While these hydrocarbons are liquid at Titan's frigid temperatures of -180 degrees Celsius, they could potentially support forms of life based entirely on different chemistry. Instead of water as a solvent, life might use liquid methane. Instead of carbon-oxygen chemistry, it might be based on silicon-nitrogen compounds. The concept of silicon-based life has long been a staple of science fiction, but serious astrobiologists now consider it a genuine possibility. Silicon can form complex molecules similar to carbon, though these molecules are generally less stable and less diverse. However, in environments where carbon-based life would be impossible, silicon-based life might thrive. On planets around red dwarf stars, which make up about 75% of all stars in our galaxy, conditions might favor radically different forms of life. Red dwarfs emit most of their energy in the infrared spectrum, so any photosynthetic life would need to harness infrared light rather than visible light. This might result in black or dark red vegetation instead of the green plants we're familiar with on Earth. The possibility of aerial life in the atmospheres of gas giants presents another exotic scenario. In the upper atmospheres of planets like Jupiter and Saturn, temperatures and pressures might allow for liquid water droplets to exist. Hypothetical floating organisms might spend their entire lives suspended in these atmospheric layers, feeding on chemical compounds and reproducing in the dense, complex chemistry of gas giant atmospheres. Even more exotic is the possibility of plasma-based life. In environments with extremely high temperatures, such as the atmospheres of stars or the accretion disks around black holes, complex plasma structures might arise that exhibit some characteristics of life, such as self-organization, metabolism, and reproduction. While this pushes the boundaries of what we typically consider life, it illustrates how radically different alien life might be from anything we've imagined. Rogue planets, worlds that have been ejected from their solar systems and now drift through interstellar space, might harbor life in their subsurface regions. Without any star to provide warmth, these planets would be frozen on their surfaces, but radioactive decay in their cores could maintain liquid water oceans beneath thick layers of ice. Life in such environments would be completely independent of any star, representing a form of existence that could persist for billions of years in the cold depths of space. The search for life in extreme environments forces us to confront fundamental questions about the nature of life itself. What are the minimum requirements for something to be considered alive? Must life be based on carbon chemistry, or could other elements serve as the foundation for complex, self-replicating systems? These questions aren't just academic. They determine how we search for life elsewhere and what signatures we look for. The Fermi Paradox and the Great Silence. In 1950, during a casual lunch conversation at Los Alamos National Laboratory, physicist Enrico Fermi posed a question that would haunt scientists for decades. Where is everybody? This simple question encapsulates what we now call the Fermi Paradox, one of the most profound puzzles in science. The paradox is this: given the vast number of stars and potentially habitable planets in our galaxy, and given that our galaxy has existed for over 10 billion years, there should have been ample time and opportunity for intelligent life to arise and spread throughout the galaxy. Yet we see no evidence of such civilizations. The universe appears eerily quiet. Let's consider the numbers. Our galaxy contains at least 100 billion stars, many of which are older than our Sun. If even a tiny fraction of these stars host planets with intelligent life, and if even a small percentage of those civilizations develop space travel, the galaxy should be teeming with evidence of their presence. But instead, we observe what scientists call the Great Silence. This silence is particularly puzzling when we consider the concept of exponential expansion. A sufficiently advanced civilization could theoretically colonize the entire galaxy in just a few million years, even using relatively slow spacecraft traveling at a fraction of the speed of light. This timeframe is negligible compared to the age of the galaxy. Various solutions have been proposed to resolve the Fermi paradox, each with profound implications for humanity's future and our understanding of intelligence in the universe. The rare Earth hypothesis suggests that while simple life might be common in the universe, complex multicellular life is extraordinarily rare. This theory points to the numerous apparently unlikely events and conditions that led to complex life on Earth: the formation of the Moon, which stabilizes Earth's axis and creates tides; the presence of Jupiter, which acts as a gravitational shield protecting the inner planets from asteroids and comets; the particular composition of Earth's atmosphere and magnetic field. According to this hypothesis, Earth might be far more special than we realize. The emergence of eukaryotic cells, sexual reproduction, multicellular organisms, and ultimately intelligence might require such specific conditions that it occurs on only a tiny fraction of potentially habitable worlds. The Great Filter hypothesis proposes that there is some stage in the evolution of life that is extremely difficult to pass. This filter could be behind us, meaning we've already passed the most difficult step, or it could be ahead of us, representing a challenge that most civilizations fail to overcome. If the Great Filter is behind us, it might be the origin of life itself, the development of complex cells, or the evolution of intelligence. This would be good news for humanity, as it would mean we've already overcome the most difficult hurdle. But if the Great Filter lies ahead of us, it suggests that something typically destroys civilizations before they can spread throughout the galaxy. This could be nuclear warfare, environmental collapse, artificial intelligence, or some other catastrophic risk that we haven't yet encountered. The dark forest hypothesis, popularized by science fiction author Liu Cixin, offers a more chilling explanation for the Great Silence. According to this theory, the universe is like a dark forest where civilizations hide from each other because revealing your presence invites destruction. In this scenario, advanced civilizations remain quiet not because they don't exist, but because they fear detection by even more advanced civilizations. This theory suggests that broadcasting our presence into space, as we've been doing through radio and television transmissions for nearly a century, might be extremely dangerous. It implies that civilizations that survive do so by remaining hidden, and those that advertise their existence are eliminated by more powerful neighbors. Another possibility is that advanced civilizations transcend physical space entirely. Perhaps sufficiently advanced intelligence naturally turns inward, creating virtual universes or exploring higher dimensions of existence rather than expanding outward through physical space. In this scenario, the galaxy might be full of advanced civilizations that we simply can't detect because they operate on scales or in dimensions beyond our current understanding. The zoo hypothesis suggests that advanced civilizations are aware of us but have chosen not to interfere, treating Earth like a nature preserve or zoo exhibit. This would explain why we don't see evidence of their presence while still allowing for a galaxy populated with intelligent life. Some scientists propose that we're looking for the wrong signs of intelligence. We search for radio signals and evidence of large-scale engineering projects, but truly advanced civilizations might use communication methods or energy sources that we can't detect or don't recognize. They might have learned to harness dark matter, manipulate space-time, or use quantum entanglement for instantaneous communication across vast distances. The possibility that we are alone in the galaxy, or even in the universe, carries its own profound psychological implications. If intelligence is so rare that Earth represents the only known example in our cosmic neighborhood, then humanity bears an enormous responsibility as potentially the only conscious observers of this region of space. The Fermi paradox forces us to confront uncomfortable questions about our own future. Are we approaching our own great filter? Will humanity join the ranks of civilizations that failed to overcome some crucial challenge? Or will we be among the rare few that successfully navigate the transition to becoming a spacefaring species? The search for extraterrestrial intelligence continues despite the Great Silence, driven by the recognition that the stakes couldn't be higher. The detection of even a single artificial signal from another civilization would definitively resolve the Fermi paradox and fundamentally alter our understanding of our place in the cosmos. Advanced detection technologies and SETI. The search for extraterrestrial intelligence has evolved dramatically since its inception, employing increasingly sophisticated technologies and methodologies to scan the cosmos for signs of alien civilizations. Traditional SETI efforts focused primarily on radio signals, based on the assumption that advanced civilizations would use radio waves for communication just as we do. The famous "wow" signal, detected by the Big Ear radio telescope in 1977, remains one of the most intriguing potential detections in SETI history. The signal lasted 72 seconds and was so strong and unusual that astronomer Jerry Emin wrote, "Wow," in the margin of the computer printout. Despite numerous attempts, the signal has never been detected again, leaving its origin a mystery. Modern SETI efforts have expanded far beyond traditional radio searches. Optical SETI looks for brief, intense flashes of laser light that might represent attempts at communication by alien civilizations. These laser pulses could be detectable across interstellar distances and would stand out dramatically against the steady light from stars. The concept of technosignatures has broadened the scope of what SETI researchers look for. These are signs of technology rather than biology, potentially detectable across vast distances. Dyson spheres, hypothetical megastructures built around stars to capture their energy output, would cause characteristic dimming patterns as they orbited their host stars. While no confirmed Dyson spheres have been found, unusual dimming patterns in stars like Tabby's star have generated intense interest and investigation. Industrial pollution in the atmospheres of distant planets could serve as another technosignature. Chlorofluorocarbons, nitrogen compounds from agriculture, or even nuclear fallout might be detectable in the atmospheres of exoplanets, indicating the presence of an industrial civilization. Breakthrough Listen, one of the most ambitious SETI projects ever undertaken, is conducting the most comprehensive search for alien signals in history. Using some of the world's most powerful telescopes, the project is surveying millions of stars and thousands of galaxies, looking for any artificial signals that might indicate intelligent life. The project employs machine learning algorithms to sift through enormous amounts of data, looking for patterns that might indicate artificial origin. These algorithms can detect signals that would be impossible for human observers to identify, processing terabytes of data from radio telescopes around the world. One of the most intriguing aspects of modern SETI is the search for signals that might not be intended for communication at all. Advanced civilizations might use powerful transmitters for their own purposes, such as interstellar communication networks or power transmission systems, and we might be able to detect these signals even if they're not directed toward Earth. The Square Kilometre Array, currently under construction in Australia and South Africa, will be the most powerful radio telescope ever built when completed. Its collecting area will be equivalent to a dish 1 square kilometer in area, giving it unprecedented sensitivity for detecting faint signals from across the galaxy. This increased sensitivity comes with its own challenges. More powerful telescopes detect more signals, but the vast majority of these are terrestrial interference, or natural astronomical phenomena. Distinguishing genuine extraterrestrial signals from this background noise requires increasingly sophisticated analysis techniques. The time scales involved in SETI searches are psychologically challenging. Even if alien civilizations are broadcasting powerful signals, they might only do so for brief periods, or their signals might be directed away from us most of the time. A comprehensive search might require monitoring target stars for decades or even centuries. Fast radio bursts represent one of the most mysterious phenomena in modern astronomy. These extremely brief, intense pulses of radio energy appear to come from distant galaxies, and their origin remains unknown. While most astronomers believe they result from natural astrophysical processes, some researchers have suggested that the most unusual FRBs might represent alien technology. The possibility of detecting alien artificial intelligence rather than biological intelligence adds another layer of complexity to SETI searches. Advanced civilizations might have long since transferred their consciousness to artificial substrates, creating forms of intelligence that might communicate in ways we don't expect or understand. Quantum communication represents a potential blind spot in traditional SETI approaches. If advanced civilizations use quantum entanglement for instantaneous communication across any distance, their signals would be undetectable using conventional radio telescopes. We might be surrounded by a rich network of quantum communications that we simply don't know how to detect. The cultural and psychological preparation for contact represents an often overlooked aspect of SETI research. The detection of an extraterrestrial signal would trigger one of the most significant events in human history. Protocols exist for verifying and announcing such a discovery, but the broader implications for human society, religion, politics, and psychology remain largely unexplored. Some researchers advocate for active SETI, deliberately transmitting powerful signals toward promising target stars in hopes of attracting attention from alien civilizations. However, this approach remains controversial, with critics arguing that advertising our presence might be dangerous until we better understand what kinds of civilizations might be out there. The democratization of SETI through projects like SETI at Home has allowed millions of people around the world to participate in the search for extraterrestrial intelligence. Volunteers donate their computer processing power to analyze radio telescope data, creating a distributed supercomputer dedicated to searching for alien signals. Perhaps most importantly, modern SETI research has begun to address the question of what we would do if we actually detected an alien signal. The mere confirmation that intelligence exists elsewhere in the universe would profoundly impact human civilization, regardless of whether we could communicate with or understand the aliens responsible for the signal. The psychological impact of successful SETI detection cannot be overstated. It would represent the end of humanity's cosmic loneliness and the beginning of a new chapter in our species' development. We would know, definitively, that intelligence and consciousness are not unique to Earth, but are properties of the universe itself. The psychology of contact. The prospect of making contact with extraterrestrial intelligence raises profound psychological questions that humanity has never before had to confront. How would the confirmation that we are not alone in the universe affect human consciousness, society, and our sense of meaning and purpose? Historical precedents offer some insight into how humans respond to paradigm-shifting discoveries. When Galileo confirmed that Earth orbits the Sun rather than being the center of the universe, the psychological impact was enormous. The realization challenged fundamental religious and philosophical beliefs about humanity's special place in creation. Similarly, Darwin's theory of evolution forced humans to confront their biological relationship to other animals, fundamentally altering our self-conception. The discovery of extraterrestrial intelligence would represent a psychological shift of even greater magnitude. For the first time in human history, we would know that consciousness and intelligence are not unique to our species or even to our planet. This knowledge would force us to reconsider virtually every aspect of human culture, from religion to philosophy to politics. Religious communities would face particularly profound challenges. Many of the world's major religions place humanity at the center of creation, with humans having a special relationship with divine beings. The existence of alien intelligence would force re-examination of these beliefs. Are humans the only beings created in God's image? Do aliens have souls? Are they subject to the same moral laws that govern human behavior? Some religious scholars have already begun to grapple with these questions. The Vatican maintains an astronomical observatory and has stated that the discovery of extraterrestrial life would not necessarily conflict with Catholic doctrine. However, the broader religious community has yet to seriously confront the theological implications of contact with alien intelligence. The psychological concept of cosmic loneliness suggests that humans have an inherent need to believe they are not alone in the universe. This loneliness might explain the persistent popularity of UFO sightings, alien abduction stories, and science fiction narratives about extraterrestrial contact. The confirmation of alien intelligence might actually fulfill a deep psychological need, providing comfort rather than causing distress. However, the nature of the aliens we might encounter could dramatically affect the psychological response. Contact with benevolent, advanced civilizations that could help solve human problems might be welcomed enthusiastically. But contact with hostile or indifferent aliens might trigger existential anxiety on a global scale. The concept of cognitive dissonance helps explain how humans might respond to contact with radically different forms of intelligence. When confronted with information that conflicts with strongly held beliefs, people often experience psychological discomfort and may reject or rationalize away the conflicting information. Some individuals might refuse to accept the reality of alien contact, insisting that it must be a hoax or misinterpretation. Cultural differences in response to contact could create significant social tensions. Some societies might embrace the knowledge of alien intelligence as confirmation of their spiritual beliefs, while others might see it as a threat to their cultural identity. These differences could exacerbate existing conflicts or create entirely new sources of social division. The Dunning-Kruger effect suggests that people with limited knowledge about a subject often overestimate their understanding of it. In the context of alien contact, this could lead to widespread misconceptions about the aliens' intentions, capabilities, and nature. Social media and popular culture might amplify these misconceptions, creating a distorted public understanding of the contact event. Children might adapt to the knowledge of alien intelligence more readily than adults, as their worldviews are still forming and they haven't yet developed strong preconceptions about humanity's uniqueness in the universe. This generational difference could create interesting social dynamics, with younger people potentially serving as bridges between human and alien perspectives. The anticipation of contact might prove psychologically significant even before any actual detection occurs. As our search capabilities improve and the probability of detection increases, societies might begin to prepare psychologically for the possibility of contact. This preparation could itself change how humans think about their place in the universe. Contact with alien intelligence would likely trigger what psychologists call post-traumatic growth, where individuals develop greater appreciation for life, stronger relationships, and an enhanced sense of personal strength after confronting significant challenges. On a species level, contact might catalyze similar positive changes in human consciousness and society. The concept of the overview effect, experienced by astronauts who see Earth from space, provides another model for understanding the potential psychological impact of contact. Astronauts often report a profound shift in consciousness, seeing Earth as a fragile, interconnected system without the political boundaries that seem so important from the surface. Contact with aliens might trigger a similar shift, helping humans see themselves as part of a larger cosmic community. However, the psychological preparation for contact raises ethical questions. Should governments and educational institutions begin preparing their populations for the possibility of contact? Would such preparation help reduce potential negative psychological impacts, Or would it create unnecessary anxiety about events that might never occur? The role of scientific literacy in psychological preparation for contact cannot be overstated. Populations with better understanding of astronomy, biology, and physics might be better equipped to process and integrate the reality of alien intelligence. This suggests that science education might play a crucial role in preparing humanity for one of the most significant events in our species' history. Perhaps most importantly, the psychology of contact would likely evolve over time. Initial shock and disorientation might give way to curiosity and eventual acceptance. Humans have repeatedly demonstrated remarkable adaptability to new realities, and contact with alien intelligence might ultimately prove to be another milestone in our species' ongoing psychological evolution. The future of astrobiology. Astrobiology, the study of life in the universe, stands at the threshold of potentially revolutionary discoveries. The convergence of advancing technologies, expanding theoretical frameworks, and mounting evidence for the ubiquity of potentially habitable worlds suggests that we may be entering a golden age of astrobiology research. The next generation of space telescopes will provide unprecedented capabilities for detecting and analyzing exoplanet atmospheres. The James Webb Space Telescope is already delivering remarkable results, but future telescopes like the Extremely Large Telescope and the Habitable Exoplanet Observatory will offer even greater sensitivity and resolution. These instruments will be capable of directly imaging Earth-sized planets around nearby stars and analyzing their atmospheric compositions in detail. The development of coronagraph technology, which blocks out the overwhelming light from stars to reveal much fainter planets orbiting them, represents a crucial advancement. Current exoplanet detection methods rely mostly on indirect techniques like measuring the dimming of starlight as planets pass in front of their stars. Direct imaging would allow us to study exoplanet atmospheres, seasons, weather patterns, and potentially even surface features. Spectroscopy, the analysis of light to determine the chemical composition of distant objects, will become increasingly sophisticated. Future instruments will be able to detect trace gases in exoplanet atmospheres at concentrations that would indicate biological activity. We might even be able to detect seasonal variations in atmospheric composition, which could suggest large-scale biological processes like photosynthesis cycles. Machine learning and artificial intelligence are revolutionizing how we analyze the enormous datasets generated by modern telescopes. AI algorithms can identify patterns in atmospheric spectra that human scientists might miss, potentially discovering biosignatures that we don't yet know to look for. These systems can process data from thousands of exoplanets simultaneously, dramatically accelerating the pace of discovery. The concept of biosignature libraries is becoming increasingly important. Scientists are compiling comprehensive databases of the spectral signatures that different forms of life might produce, including not just Earth-like biology but exotic alternatives like silicon-based life or organisms that use different solvents than water. These libraries will help us recognize signs of life even when they don't match terrestrial patterns. Interstellar probe missions represent the ultimate goal of astrobiology research. While current technology makes such missions extremely challenging, concepts like breakthrough starshot propose using light sails powered by powerful lasers to accelerate tiny probes to significant fractions of the speed of light. These probes could reach the nearest potentially habitable exoplanets within decades rather than millennia. The search for life is also expanding beyond traditional targets. Scientists are now seriously considering the possibility of life in the upper atmospheres of Venus, where temperatures and pressures might allow for liquid water droplets suspended in sulfuric acid clouds. The recent detection of phosphine in Venus's atmosphere has sparked intense debate about whether this could indicate aerial microorganisms. Mars continues to yield surprises that fuel speculation about past or present life. The Perseverance rover has collected samples that show clear evidence of ancient river deltas and lake beds, environments that could have supported life billions of years ago. The planned Mars sample return mission will bring these samples back to Earth for detailed analysis that could finally answer the question of whether life ever existed on Mars. Europa and Enceladus, moons of Jupiter and Saturn respectively, are now recognized as some of the most promising targets in our search for life. Both moons have subsurface oceans that contain more water than all of Earth's oceans combined. Future missions will attempt to sample the water plumes that erupt from these moons' surfaces, potentially bringing us face to face with extraterrestrial microorganisms. The development of life detection instruments is advancing rapidly. New technologies can identify biological molecules, detect metabolic processes, and even recognize the complex organic chemistry that characterizes living systems. Some of these instruments are becoming sensitive enough to detect a single living cell in a sample, opening up possibilities for finding life even in seemingly sterile environments. Synthetic biology is contributing to astrobiology research by helping scientists understand the fundamental requirements for life. By creating artificial biological systems and testing their limits, researchers can better understand what forms life might take under different conditions. This research might even help us create Earth-based analogs of alien life forms, allowing us to study their properties in detail. The timeline for major astrobiology discoveries is difficult to predict, but many scientists believe we're entering a period of rapid advancement. The combination of improving detection capabilities, expanding search targets, and growing theoretical understanding suggests that the next few decades could see unprecedented discoveries about life in the universe. But what happens when we actually find life? The detection of even microbial life beyond Earth would trigger a cascade of follow-up questions and investigations. Is this life related to Earth life, suggesting a common origin or panspermia? Or is it completely independent, proving that life can arise through multiple pathways? How widespread is life in the universe? The societal implications of discovering extraterrestrial life would be enormous. Scientific funding for space exploration and astrobiology research would likely increase dramatically. Public interest in science and space exploration would surge. Educational curricula would need to be updated to reflect humanity's new understanding of its place in the universe. International cooperation in astrobiology research is becoming increasingly important as the scale and cost of major missions exceed what any single nation can undertake. The search for life is becoming a truly global endeavor, uniting scientists from different countries in pursuit of answers to questions that affect all of humanity. The philosophical implications of astrobiology research extend far beyond science. If life is common in the universe, it suggests that consciousness and intelligence might also be widespread. This would fundamentally change how we think about the nature of mind, the possibility of communication with non-human intelligence, and our responsibilities as one of potentially many intelligent species. The economic implications of astrobiology discoveries could be substantial. The confirmation of life elsewhere might trigger new industries focused on communication, resource extraction, or even tourism to other worlds. The technologies developed for detecting and studying extraterrestrial life might find applications in medicine, environmental monitoring, and other fields. Perhaps most importantly, astrobiology research is changing how we think about Earth itself. By studying the conditions necessary for life and the factors that make planets habitable, we gain new perspective on the preciousness and fragility of our own world. The search for life elsewhere ultimately helps us better understand and protect the life we know exists here on Earth. Before we dive deeper into the mind-bending possibilities ahead, I want to hear from you again. What aspect of the search for alien life fascinates you most? Are you more intrigued by the possibility of finding microbes in our own solar system, Or does the prospect of detecting advanced civilizations around distant stars capture your imagination? Share your thoughts in the comments, and let me know what questions about extraterrestrial life keep you awake at night. Implications for humanity's future. The discovery of extraterrestrial life, whether microbial or intelligent, would represent a watershed moment in human history, fundamentally altering our species' trajectory and our understanding of our place in the cosmic order. The implications stretch far beyond the realm of science, touching every aspect of human existence from philosophy to politics, from religion to economics. Consider first the impact on human consciousness itself. For over 200,000 years, humans have developed their cultures, religions, and worldviews under the assumption that Earth represents the only known island of life in an otherwise sterile universe. This assumption has profoundly shaped our sense of purpose, our moral frameworks, and our understanding of consciousness itself. The confirmation that life exists elsewhere would shatter this fundamental assumption. We would suddenly find ourselves not as the sole conscious observers of reality, but as members of a cosmic community of life. This shift could trigger what anthropologists call a phase transition in human consciousness, similar to the agricultural revolution or the development of written language. From an evolutionary psychology perspective, humans have evolved as a highly social species with complex mechanisms for distinguishing between us and them. These mechanisms helped our ancestors survive in small tribal groups, but they also contribute to modern problems like racism, nationalism, and xenophobia. Contact with truly alien intelligence might force humanity to expand its definition of us to include non-human consciousness, potentially reducing conflicts between different human groups. The economic implications of discovering extraterrestrial life could be transformative. New industries would emerge overnight: xenobiology research, interstellar communication systems, and eventually perhaps trade with alien civilizations. The technologies developed for detecting and communicating with aliens would likely find applications in numerous other fields, driving innovation and economic growth. Space exploration budgets would almost certainly increase dramatically following the confirmation of extraterrestrial life. Public interest and political support for space missions would surge, potentially leading to a new space race focused not on national prestige but on making contact with alien life. This increased investment could accelerate technological development and bring forward the timeline for human expansion beyond Earth. The discovery of alien life might also provide crucial insights into solving problems on Earth. Alien organisms adapted to extreme environments could inspire new approaches to treating diseases, developing sustainable technologies, or surviving in harsh conditions. If we discovered advanced alien civilizations, they might have already solved problems that currently seem intractable to us, such as sustainable energy, environmental restoration, or interstellar travel. However, the implications wouldn't all be positive. The knowledge that advanced alien civilizations exist might trigger what philosophers call existential risk anxiety. If aliens are far more advanced than humans, we might feel vulnerable or insignificant by comparison. This could lead to increased international tensions as nations compete to develop better defenses against potential alien threats, even if no such threats actually exist. Religious institutions would face unprecedented challenges in adapting their doctrines to accommodate the reality of alien life. While some faiths might successfully integrate this knowledge, others might fragment or decline if their core beliefs prove incompatible with the existence of non-human consciousness. New spiritual movements might emerge that specifically address humanity's place in a universe populated with alien life. The legal and political implications are equally complex. Current international law is based entirely on human societies and human rights. The discovery of alien intelligence would require developing entirely new frameworks for interspecies relations. Questions about alien rights, the ethics of contact, and the governance of interstellar communication would need to be addressed. Educational systems would need fundamental restructuring to prepare future generations for life in a universe where humans are not alone. Science curricula would expand dramatically to include astrobiology, xenopsychology, and interstellar communication. Philosophy and ethics courses would grapple with questions about the nature of consciousness and the rights of non-human intelligence. The psychological preparation for contact represents one of the most overlooked aspects of astrobiology. Mental health professionals are only beginning to consider how humans might react to confirmation of alien life. While some individuals might thrive on the excitement and possibilities, others might experience anxiety, depression, or existential crisis when confronted with evidence that humans are not unique. Cultural diversity in responses to alien contact could create new sources of social tension. Different societies might interpret the significance of alien life through their existing cultural lenses, leading to conflicting views about how to respond to contact. These differences could exacerbate existing political tensions or create entirely new forms of conflict. The impact on human creativity and artistic expression would likely be profound. Literature, music, visual arts, and film would all grapple with the new reality of alien life. New art forms might emerge specifically designed to communicate across species barriers. The entire genre of science fiction would need to reinvent itself once some of its central premises became scientific fact. Long-term evolutionary implications also deserve consideration. If humans eventually make contact with advanced alien civilizations, we might gain access to technologies and knowledge that could direct our own evolution. Genetic engineering, artificial intelligence, and life extension technologies developed or inspired by alien contact could fundamentally alter what it means to be human. The possibility of joining a galactic community of intelligent species represents perhaps the most profound long-term implication. Humanity might eventually transition from a single-planet species to participants in a vast network of interstellar civilizations. This transition would require developing new forms of government, economics, and social organization adapted to the scale and complexity of galactic society. Yet even in the absence of contact with intelligent aliens, the mere confirmation that life exists elsewhere would begin this transformation process. Knowing that we share the universe with other living beings would change how we see ourselves and our responsibilities. We might develop a greater sense of stewardship for life in general, both on Earth and potentially elsewhere in the universe. The timeline for these changes would depend heavily on the nature of the discovery. Finding microbial life on Mars or Europa would trigger significant but gradual changes over decades. Detecting signals from an advanced alien civilization would likely cause more immediate and dramatic shifts in human consciousness and society. Preparing for these possibilities represents one of the great challenges of our time. Unlike natural disasters or economic crises, the discovery of extraterrestrial life would be unprecedented in human experience. We have no historical models to guide our response, and no established institutions designed to handle such a paradigm shift. Current missions and future discoveries. As we speak, robotic explorers across our solar system are actively searching for signs of life, while ground-based telescopes scan the skies for potentially habitable worlds. These missions represent humanity's most ambitious attempt to answer the fundamental question of whether we are alone in the universe. NASA's Perseverance rover continues its methodical exploration of Jezero crater on Mars, a location chosen specifically for its potential to preserve signs of ancient life. The rover has already confirmed that the crater once held a large lake fed by rivers, creating exactly the kind of environment where life might have emerged billions of years ago. Perseverance is currently collecting rock samples that will eventually be returned to Earth for detailed analysis by the most sophisticated instruments available. The Mars Sample Return Mission, a joint effort between NASA and the European Space Agency, represents one of the most complex robotic missions ever attempted. The samples collected by Perseverance will be launched from the Martian surface by a small rocket, caught in Mars orbit by another spacecraft, and eventually returned to Earth for analysis. These samples could provide definitive evidence of past life on Mars, or at least reveal the chemical conditions that existed when Mars was more hospitable to life. Europa Clipper, scheduled to launch in 2024, will conduct detailed reconnaissance of Jupiter's ice-covered moon Europa. The spacecraft will make dozens of flybys of Europa, using ice-penetrating radar to confirm the existence of the subsurface ocean and analyze the composition of water plumes that erupt from the moon's surface. If Europa's ocean contains the chemical ingredients necessary for life, future missions might attempt to land on the surface and drill through the ice to sample the ocean directly. The upcoming Dragonfly mission to Saturn's moon Titan represents a completely new approach to exploring potentially habitable worlds. Rather than a traditional rover or lander, Dragonfly is a nuclear-powered drone that will fly from location to location across Titan's surface, analyzing the complex organic chemistry that might have led to the emergence of life in Titan's methane lakes and rivers. Ground-based efforts to find life are advancing just as rapidly. The TRAPPIST-1 system, located just 40 light-years from Earth, contains 7 Earth-sized planets, several of which orbit within the habitable zone where liquid water could exist on their surfaces. The James Webb Space Telescope has already begun analyzing the atmospheres of these planets, searching for the chemical signatures that would indicate the presence of life. The detection of water vapor in the atmosphere of K2-18b, a subneptune exoplanet located 124 light-years away, demonstrates the incredible precision of modern astronomical instruments. While K2-18b is too large and receives too much radiation to host Earth-like life, the detection of water in its atmosphere proves that we can identify potentially habitable conditions on worlds dozens of light-years away. Breakthrough Listen continues to scan the skies for artificial signals that might indicate the presence of technological civilizations. The project has already analyzed data from millions of stars and thousands of galaxies, ruling out powerful radio transmissions from vast regions of space. While no confirmed alien signals have been detected, each negative result helps constrain the prevalence and behavior of advanced civilizations in our galaxy. The upcoming square-kilometer array will increase our sensitivity to potential alien signals by several orders of magnitude. This massive radio telescope, distributed across thousands of individual antennas in Australia and South Africa, will be capable of detecting cell phone-strength signals from nearby star systems. It will also be able to image the formation of the first stars and galaxies, potentially revealing how common Earth-like conditions are throughout cosmic history. Private efforts to search for life are also advancing rapidly. The SETI Institute continues to develop new strategies for detecting alien intelligence, including optical SETI programs that search for brief laser flashes that might represent attempts at interstellar communication. The Planetary Society funds research into advanced propulsion systems that could eventually carry robotic probes to nearby star systems. Citizen science projects allow millions of people around the world to participate directly in the search for extraterrestrial life. Planet Hunters uses crowdsourced analysis to identify potentially habitable exoplanets in telescope data, while SETI at Home distributed computing projects process radio telescope data searching for artificial signals. The timeline for potential discoveries is impossible to predict with certainty, but several key milestones could occur within the next decade. The James Webb Space Telescope might detect atmospheric biosignatures on nearby exoplanets, providing strong evidence for life beyond our solar system. Mars sample return could reveal fossilized microorganisms or organic molecules that strongly suggest past life on Mars. Europa Clipper and future missions to icy moons could discover active ecosystems in the subsurface oceans of Europa, Enceladus, or other moons. These discoveries would prove that life can exist in environments completely cut off from sunlight, dramatically expanding our understanding of habitability throughout the universe. The development of increasingly powerful artificial intelligence systems might revolutionize how we analyze data from these missions. AI algorithms could identify patterns or anomalies in atmospheric spectra, geological formations, or radio signals that human scientists might miss. Machine learning systems trained on Earth's biosignatures might be able to recognize completely alien forms of life that don't match terrestrial patterns. Interstellar probe concepts are advancing from science fiction toward engineering reality. Breakthrough Starshot aims to demonstrate the feasibility of using powerful lasers to accelerate lightweight probes to 15 to 20% of the speed of light, potentially reaching the nearest star systems within 20 to 30 years of launch. While current technology cannot yet achieve these goals, rapid advances in materials science and laser technology suggest that interstellar probes might be possible within decades rather than centuries. The coordination between different missions and observatories is becoming increasingly sophisticated. When one telescope detects an intriguing signal or atmospheric signature, other instruments around the world can quickly be redirected to confirm and analyze the discovery. This global network of observers dramatically increases our chances of recognizing and confirming signs of extraterrestrial life. The data sharing and analysis capabilities of modern astronomy mean that discoveries can be verified and understood much more rapidly than in the past. When unusual signals or atmospheric compositions are detected, the data can be shared instantly with researchers around the world, allowing multiple independent teams to analyze the same observations and confirm or refute potential signs of life. Perhaps most importantly, the cumulative effect of all these missions and observations is building a comprehensive picture of habitability throughout the universe. Even if none of these specific missions finds definitive proof of extraterrestrial life, they are mapping the distribution of potentially habitable worlds and constraining the conditions under which life might arise. The psychological preparation for these potential discoveries is as important as the technical preparation. As our detection capabilities improve and our survey of potentially habitable worlds becomes more complete, the probability of finding evidence for extraterrestrial life continues to increase. We may be approaching a time when the question is not whether we will find alien life, but when and where we will find it first. The profound questions ahead. As we stand on the threshold of potentially discovering life beyond Earth, we must grapple with questions that challenge the very foundations of human knowledge and self-understanding. These questions go far beyond the technical aspects of detection and analysis. They probe the deepest mysteries of consciousness, purpose, and meaning in a universe that might be teeming with life. What would it mean for human consciousness to encounter genuinely alien consciousness? This question strikes at the heart of cognitive science and philosophy of mind. Human consciousness, despite its complexity and mystery, operates within certain parameters shaped by billions of years of evolution on Earth. We experience time linearly, perceive reality through specific sensory modalities, and process information using neural networks that emerge from terrestrial evolutionary pressures. Alien consciousness might operate on completely different principles. Imagine beings that experience time nonlinearly, perceiving past, present, and future simultaneously. Or consider intelligence that exists as distributed networks across multiple bodies, sharing thoughts and memories instantaneously. Such forms of consciousness would challenge our most basic assumptions about the nature of mind and identity. The question of whether consciousness is substrate independent becomes crucial when considering artificial alien intelligence. Advanced extraterrestrial civilizations might have long since transferred their consciousness to silicon-based or quantum computing systems, existing as pure information capable of surviving the death of their biological creators. Would we even recognize such beings as conscious, or would their thought processes be so alien that we might mistake them for natural phenomena? Communication with alien intelligence presents paradoxes that linguists and cognitive scientists are only beginning to explore. Human language is deeply embedded in our biological and cultural evolution. We use metaphors based on our physical experience of the world, concepts shaped by our social structures, and logical frameworks that reflect how human brains process information. How would we communicate with beings that don't share our evolutionary history or physical constraints? The challenge goes beyond simple vocabulary or grammar differences. It extends to the fundamental conceptual frameworks that underlie all communication. Aliens might not have concepts analogous to our notions of self, time, causation, or even existence itself. The temporal scales involved in interstellar communication add another layer of complexity. Even at the speed of light, conversations with civilizations around nearby stars would involve decades-long delays between messages and responses. This means that any communication would necessarily be more like correspondence between generations than real-time conversation. But perhaps the most profound questions concern the implications of alien intelligence for human purpose and meaning. Throughout history, humans have derived meaning from various sources: religious beliefs about our special relationship with divine beings, philosophical concepts about the uniqueness of human consciousness, or scientific narratives about our role as the universe's way of understanding itself. The discovery of alien intelligence would require fundamental revision of all these meaning-making frameworks. If consciousness and intelligence are common in the universe, what makes human consciousness special? If advanced alien civilizations have already explored the deepest mysteries of existence, what unique contribution can humanity make to cosmic understanding? Some philosophers suggest that the discovery of alien intelligence might actually enhance rather than diminish human meaning. If consciousness is a fundamental feature of the universe rather than a biological accident, then participating in the cosmic community of conscious beings might represent a form of transcendence beyond anything humans have previously imagined. The question of alien values and ethics presents equally challenging puzzles. Human morality evolved from our nature as social primates living in small groups where cooperation and reciprocity provided survival advantages. Alien beings with different evolutionary histories might have developed entirely different ethical frameworks. Would alien civilizations share human concepts like compassion, justice, or individual rights? Or might they operate according to moral principles so alien that we would find their behavior incomprehensible, or even abhorrent? The possibility that advanced alien civilizations might be fundamentally amoral or hostile forces us to confront uncomfortable questions about the relationship between intelligence and ethics. The implications for human religion and spirituality represent another profound area of inquiry. Most of Earth's religious traditions developed in isolation from any knowledge of alien life, focusing on humanity's relationship with divine beings or ultimate reality. The confirmation of alien intelligence would require extensive theological revision. Some religious scholars argue that the existence of alien intelligence would actually strengthen rather than weaken religious faith, providing evidence that consciousness and intelligence are fundamental features of creation rather than biological accidents. Others worry that contact with advanced alien civilizations might reveal that human religious concepts are parochial and primitive compared to alien spiritual understanding. The question of technological singularity becomes more complex when considered in the context of alien intelligence. If advanced alien civilizations have already achieved artificial general intelligence and technological singularity, what can we learn from their experience? Did they successfully navigate the transition from biological to artificial intelligence? Or do the galaxy's most advanced civilizations represent post-singularity entities that have transcended their biological origins entirely? The possibility that we might encounter artificial alien intelligence rather than biological aliens raises profound questions about the nature of consciousness and identity. If an alien civilization created artificial intelligence that subsequently replaced its creators, would that artificial intelligence still represent the original civilization? Would it retain any connection to its biological origins, or would it have evolved into something entirely different? Environmental and planetary considerations also raise deep questions about alien life. Would advanced alien civilizations necessarily follow sustainable development paths, or might they exhaust their planetary resources and move on to new worlds? If we discovered evidence of civilizations that destroyed their home planets, what would that tell us about the long-term prospects for intelligence in the universe? The concept of cosmic evolution suggests that the universe itself might be evolving toward greater complexity and consciousness. In this view, the emergence of intelligence represents a natural progression in cosmic development, with conscious beings eventually gaining the ability to direct the universe's future evolution. If this perspective is correct, then discovering alien intelligence would confirm that consciousness plays a fundamental role in cosmic development. Humanity and alien civilizations alike might be part of a vast cosmic process leading towards some form of universal consciousness or intelligence. Perhaps most fundamentally, the search for alien intelligence forces us to confront the limits of human knowledge and understanding. There may be aspects of reality, consciousness, and existence that are simply beyond human comprehension, regardless of how advanced our science and technology become. The discovery of alien intelligence might reveal the boundaries of human understanding, while simultaneously opening up entirely new realms of knowledge. We might find ourselves in the position of children trying to understand adult concepts, capable of recognizing that greater understanding exists, but unable to grasp its full implications. As we continue our search for life beyond Earth, we must prepare not just our instruments and analytical techniques, but our minds and our cultures for discoveries that could fundamentally transform human civilization. The questions we're exploring don't have easy answers, but engaging with them seriously represents crucial preparation for what might be the most significant discovery in human history. What keeps you awake at night when you think about the possibility of alien life? Is it excitement about the scientific discoveries ahead, concern about how humanity might react to contact, or something else entirely? I'd love to hear your perspective on these profound questions in the comments below. Conclusion: our cosmic destiny. As we reach the end of this exploration into the possibilities of alien life beyond our solar system, we find ourselves standing at a unique moment in human history. Never before has our species possessed such powerful tools for detecting extraterrestrial life. Never before have we mapped so many potentially habitable worlds. And never before have we been so close to answering the fundamental question of whether we are alone in the universe. The journey we've taken together through this cosmic landscape of possibilities reveals a universe far stranger and more wonderful than our ancestors could have imagined. From the billions of exoplanets that orbit distant stars to the exotic forms of life that might thrive in environments we once thought impossible. From the technologies that might detect alien signals to the profound questions that such discoveries would raise, we've explored a frontier that exists at the very edge of human knowledge and imagination. The statistical arguments alone suggest that alien life not only exists but might be common throughout the universe. With trillions of galaxies each containing billions of stars, many hosting potentially habitable planets, the cosmic lottery has been played so many times that life seems almost inevitable. The question isn't whether alien life exists, but whether we'll be clever enough and persistent enough to find it. Yet the search for extraterrestrial life represents more than just a scientific endeavor. It's a mirror that reflects our deepest hopes and fears about our place in the cosmos. When we search for aliens, we're really searching for ourselves, trying to understand what it means to be conscious beings in a universe that might be filled with other conscious beings. The technologies we're developing in this search are already transforming our understanding of our own planet and our own biology. The instruments designed to detect alien biosignatures are providing new insights into Earth's climate and ecosystem. The theories developed to understand alien psychology are illuminating aspects of human consciousness we never recognized before. But perhaps most importantly, the search for alien life is changing how we think about our responsibilities as potentially one of many intelligent species in the universe. If life is common, then consciousness might be a fundamental feature of cosmic evolution, and intelligence might play a crucial role in the universe's future development. The timeline for discovery remains uncertain, but the trajectory is clear. Our detection capabilities improve exponentially each year. Our catalog of potentially habitable worlds grows daily. Our understanding of the conditions that support life expands constantly. We are approaching a tipping point where the discovery of alien life transitions from possibility to probability to inevitability. When that discovery comes, whether it's microbial life on Mars, complex ecosystems in Europa's oceans, or signals from an advanced civilization around a distant star, humanity will enter a new phase of its existence. We will know, definitively, that we are not alone, that consciousness and intelligence are not accidents but natural products of cosmic evolution. This knowledge will bring challenges and opportunities in equal measure. We'll need to develop new philosophical frameworks for understanding our place in a populated universe. We'll need new ethical systems that account for the rights and dignity of non-human intelligence. We'll need new social and political structures capable of managing humanity's relationship with alien civilizations. But we'll also gain access to new forms of knowledge, new technologies, new perspectives on existence that could help solve problems that currently seem intractable. The discovery of alien life might catalyze advances in medicine, energy, transportation, and countless other fields. More fundamentally, it might help us understand consciousness itself, providing insights into the nature of mind and reality that we could never achieve in isolation. The children growing up today might be the generation that makes first contact with alien intelligence. They might be the first humans to communicate with beings whose evolutionary history is completely separate from our own. They might be the pioneers who establish humanity's relationships with the cosmic community of intelligent beings. This possibility places an enormous responsibility on our current generation. We are laying the groundwork for humanity's cosmic future through the decisions we make today about science funding, space exploration, and the search for extraterrestrial intelligence. We are developing the technologies and theories that will guide our response to the most significant discovery in human history. The search for alien life also reminds us of the preciousness and fragility of the life we know exists on Earth. As we scan the cosmos for signs of biology, we gain new appreciation for the delicate balance of conditions that support our planet's incredible diversity of life. The search for aliens ultimately helps us better understand and protect our own world. Whether alien life proves to be microbial or intelligent, primitive or advanced, similar to Earth life or completely unlike anything we've imagined, its discovery will mark a fundamental transition in human consciousness. We will join the ranks of species that know they are not alone in the universe, that understand their place in a cosmic community of living beings. The implications stretch far beyond science into every aspect of human culture and society. Art, literature, music, philosophy, religion, politics, economics, education, and psychology will all be transformed by the knowledge that consciousness and intelligence exist elsewhere in the universe. Yet even if we never find definitive proof of alien life, the search itself is transforming humanity in profound ways. It's pushing us to develop new technologies, to ask deeper questions about the nature of life and consciousness, to think more carefully about our responsibilities as intelligent beings in a vast universe. The search forces us to confront our own limitations and assumptions while simultaneously expanding our imagination and our understanding of what's possible. It reminds us that we are part of something much larger than ourselves, participants in a cosmic story that began with the Big Bang and continues to unfold through the emergence of stars, planets, life, and consciousness. As we continue this search, we must remember that we're not just looking for alien life. We're looking for our place in the cosmic order. We're trying to understand whether consciousness represents a rare accident or a fundamental feature of reality. We're exploring whether intelligence has a purpose in the universe's ongoing evolution. The answer to these questions will shape humanity's future in ways we can barely imagine. But regardless of what we find, the search itself ennobles our species and elevates our understanding of existence. We are the universe becoming aware of itself, conscious beings capable of contemplating our own origins and our cosmic destiny. The stars await our discovery. Somewhere in that vast expanse of space and time, other beings might be conducting their own search, wondering if they are alone, hoping to make contact with civilizations like ours. The universe might be filled with intelligence, consciousness, and wonder beyond our wildest dreams. We stand at the threshold of potentially the greatest discovery in human history. The next few decades might see us transition from a species that wonders about alien life to one that knows, with certainty, that we share the cosmos with other living beings. That knowledge will change everything. The search continues. The questions multiply. The possibilities expand. And somewhere in the cosmic deep, life might be looking back at us, equally curious, equally hopeful, equally ready to discover that consciousness and intelligence represent not accidents but inevitabilities in our magnificent, mysterious universe. Thank you for joining me on this journey to the very edges of human knowledge and imagination. The universe is vast, strange, and possibly alive with forms of existence we've never dreamed of. And we, as conscious beings capable of wonder and discovery, are privileged to be part of this cosmic story as it continues to unfold. What will you do with this knowledge? How will you prepare for a future where humanity might not be alone? The answers to these questions will help shape our species' response to potentially the most significant discovery in our history. The future is vast, full of possibility, and awaiting our discovery. I'd love to hear your final thoughts on this cosmic journey we've taken together. What aspect of the search for alien life resonates most deeply with you? What questions does it raise about your own life and humanity's future? Share your reflections in the comments below, and let's continue this conversation about our place in what might be a universe teeming with life, consciousness, and wonder beyond our wildest imagination.